Hello everyone. So this is going to be section 3.2. Again, like I do every time. The first thing announcement about the homework. So the homework or web assigned homework of section 2.7 and 2.8 is due this Saturday, which is September 26, 11:59 p.m. Okay. And one thing, the correction means I'm going to correct one thing that I did in the last lecture. One of the student mentioned that in the YouTube comment. So just want to clear that. So there was an example, x to the power of 3, x to the power of 3 plus 6x squared minus 15x. And you need to find the critical number of this, right? So when I did that, this was okay. This was from section 3.1 video. I'm just going to correct one thing, one mistake I did on that video. So on this one here, when you're finding the critical number, well, I did that, all the step, everything else is okay. It's just that at the end, x plus 5, x minus 1 is equals to 0, right? And then here, I said that it is x is equals to 5 and x is equals to -1 on that video, but it should have been actually it should have been -5 and this should have been +1, right? Okay, so yeah, make sure you understand. I think everyone figured that out, figured that mistakes, but still I just want to clear this up, just in case if you guys have any kind of confusion. Yeah, this is actually the right answer. That was my mistake. All right. Anyway, okay, now this is again 3.2. So this video is going to be now a very short video. I'm going to cover just two things in this video. The first one is Rolle's theorem, and the second one is mean value theorem. The reason I'm covering this section is if you're taking some high-level math course later on, this theorem is very useful theorem later on. So just to give you an idea of what this theorem is, that's why I'm just covering this section. Okay, and I am not going to assign any web assigned homework from this section. All right, I am not going to assign, but still I might ask you a few problems from this section based on my explanation here. Okay, so there won't be any homework. I might just give you an idea in the exam review what exactly I might ask in the exam from this section. But for right now, I'm just going to explain these two theorem, give you an idea what this theorem is talking about. And based on that explanation, I might ask maybe one or two problems in the exam from this section. Okay. So like I said, there is no homework, or there is no web assigned homework from this section. Anyway, so the first one is Rolle's theorem. Okay, so the Rolle's theorem says that, okay, there is a function, okay, let's say, okay, there is a function f. Let's say, okay, this is function f. Okay, and this satisfies, okay, the function is continuous on the closed interval from a to b. So when you have this square bracket, that means we are including these in point, right? So we are including this a, here we are including this b. So in this case, in this kind of case, we call a closed interval. Okay, so let's say there is an interval a, b, and this function, this is f function. Okay, this is f function, and this function is obviously, well, you can clearly see that this is a continuous function, right? Since there is no break here, so this is continuous. And also we have a condition, second condition, f is differentiable on the open interval means open means, okay, here we have a parenthesis, right? So in this endpoint, if you have an open circle, that means for differentiable conditions, we cannot include the endpoint. For continuous, yes, we can include, well, we are including the endpoint A and B, but for differentiable conditions, we are not including, just be clear on that, okay? And also the third condition says that f of A is equals to f of B. So here, if A is this, then here we will get here f of A. And if B is this, then obviously here f of B is also exactly this point, right? So that's why we get f of A is equals to f of B. Okay, okay. So if we have these three conditions, okay, if a function satisfies these three conditions, then we can say that, okay, there is a number, there is going to be one number, okay, there is going to be one number, let's say C, such that, okay, this C, well, at this point, so at this C means, well, f prime of C means, okay, first here we'll get this point f of C, right? If I pick C here, then f of C is there. So such that this f prime of C, or f, the derivative of this is going to be 0. I have explained a similar idea as well on the last video. Yes, on the last video. Okay. So f prime means, or the derivative of a function at certain point means it is the slope of the tangent line, right? And the tangent line means there is a line which is just going to touch the graph at one point. So here, here at this point, if we make a line which is just going to touch this point here, then you will get this line a horizontal line, right? So, and the slope of a horizontal line is always 0. That's what you guys learned in the algebra, right? The slope of the horizontal line is always 0. So that's what this theorem is talking about. Okay, so make sure you understand the idea. Okay, so what I'm talking here here is, I talked about the slope of the tangent line. I talked about the slope of the horizontal line. I talked about okay, there must exist C in between A and B. So this C is just going to be that one C. Well, this C cannot be here, right? If I say C is here, we're gonna get a different tangent line. So this C must always be here, such that the f prime of C is equals to 0. So that means the slope of the tangent line is equals to 0. So that means this point is going to be at the maximum point of this graph, right? So at the maximum point, you're always going to get the vertical horizontal, the horizontal line is going, or the tangent line is just going to be a horizontal line. Okay, the tangent line is just going to be a horizontal line. Okay, so yeah, that's the idea of this theorem. Now let's go to another one, mean value theorem. Okay, so the mean value theorem, again, you will get something similar conditions here as well. Try to understand the difference between the mean value theorem and the Rolle's theorem. Okay, so the mean value theorem says that, okay, let f be a function that satisfies the following. Okay, again, f is continuous on the closed interval. So let's say A is here, B is here. So here we only have two conditions. Here on the Rolle's theorems, we had three conditions. The extra conditions here we had was f of A is equals to f of B. But here we don't have that, but that's not the only difference. We have a few other differences as well. So, okay, so f is continuous, so let's make a continuous function in this interval. Or let's, yeah, I can do that as well. Oops. Okay, so this is continuous functions, and again the f is differentiable on the open interval, like I explained in the previous this one, right? So it's the same conditions. Now here, okay, there is a c, um, there is a c in in a b such that f prime of c is equals to f of. So what I'm trying to say here is, okay. Uh, So here we don't need that f of a is equals to f of b condition. Okay, so let's make a secant line. I think I have explained the similar condition. It's pretty similar to what I explained. I think it was in 2.1 or 2.2, something like that. But okay, let's say this is a secant line. Okay, this is a secant line. So here we will get f of a. Here we'll get f of b, right? Because if this is a b, then this is going to be f of b. Okay, this is a secant line. And this theorem says that, okay, there is a number c in between a and b. It's going to be in between, right? In between a and b. So let's say it's somewhere down here. And the f prime of c means, okay, if this is a c, then f prime of c means, okay, there is a tangent line that goes through this point. So in this case, the slope of this line must be equals to slope of this line, or the slope of the tangent line must be equals to slope of the secant line, right? So this is the tangent line at C, right? And this is a secant line. And why can we say this? Okay, so now here, what is this? F of b minus f of a over b over a means this is similar to y2 minus y1 over x2 minus x1, right? Because this one, f of b is on y-axis, so I can assume this as y2, y1, and here this is an x-axis, so I can assume this as x1, y1. So y2 minus y1 over x2 minus x1 means the slope. So this means this is the slope of, this is the slope of secant line. And this is the slope of the tangent line. So here the main idea is this line here. It says that, okay, there is or there exists such a number C where we get the slope of this is equals to slope of this, or slope of the tangent line is equals to slope of the secant line. Okay, and that's what the mean value theorem talks about here. So anyway, like I said, if you have any questions, feel free to ask me during my office hour. But like I said, you need to understand the concept of these two theorems, like I explained here. Okay, I might ask something based on what I explained today in the exam. Okay, I think that's all I want to talk about from this section. Yes, but like I said, you won't have any web assigned homework from this section. Yeah, that's it. I'll see you in the next video. Thank you.